Ladies and gentlemen, please welcome back to the stage General Manager of Cloud Connect, Steve White.
Hey, good morning, everyone. Well, welcome back to Cloud Connect. We had a great first day here yesterday, and we've got many more great speakers planned for you today. So thanks for coming back. I hope a lot of you had a chance to get out and check out some of the party last night. It was great that Rackspace and Citrix hosted a great event for us, especially with so many people out of town on Valentine's Day. So a big thanks to Rackspace and Citrix for doing that. I'm going to move through the agenda pretty quickly today in the interest of time. And one of the reasons that we're doing that is because we've actually added a speaker into our lineup this morning. Zynga has been in the news quite a bit lately, and especially this week made some news. And we happen to have Alan Leinwand, who is the CTO of infrastructure at Zynga, doing a session tomorrow. So we've asked Alan to come in and jump on the main stage here and do a quick update for us as well. So we're looking forward to that. We're seeing a lot of nice comments coming in on Twitter and through the session evaluations. That's much appreciated. We really try to make Cloud Connect the conference that really leads with quality, and it's nice to see that you all appreciate the effort that's going in there into making this a quality program as well. And with that, I would like to just take a few minutes to thank our track chairs. These are the folks that have worked tirelessly over the last few months to put a great program together. So can we take a second and just give these folks a nice round of applause? Okay, some housekeeping items to go through. We're going to have a busy year here at Cloud Connect. We actually recently announced the addition of 2 new events. The next one of those will be taking place in Bangalore, India. That's happening in May. And then in September, we have Cloud Connect Chicago. So we're going to have a very busy year. The call for papers for both of those events is now open. So if you're sitting in sessions this week and thinking there's a topic that we really need to be covering here, Cloud Connect's call for papers is open for both of those events, and you can get more information on that on our website. There we go. We've got some fun stuff again planned for tonight. So today on the show floor, 4:30 to 6 o'clock, the folks at Nuvem will be hosting a cocktail reception on the show floor. Come down, have a drink after your sessions today, and network with your peers. And then tonight we have the GoGrid party happening from 6 o'clock to 8 o'clock in the Hyatt mezzanine. That's the second floor level above the registration area over in the Hyatt. So come down and check out that. And then, at Cloud Connect, of course, we're a real serious bunch. So we thought it would be interesting to do a little just audience profile just to see the kind of the type of attendees that are showing up at Cloud Connect these days. So this is, I mentioned yesterday we were doing our photo booth thing down on the show floor. These are a few of the pictures that we thought were especially funny. So make sure you head down to the photo booth, check in there with our mobile app, and join these wonderful people here on our picture profile. Okay, we're going to jump right into the program now. Our first speaker is a true pioneer in cloud computing. When he was CTO of IT and CIO of the Ames Research Center at NASA, he co-founded the OpenStack project. And of course, OpenStack has had a huge impact throughout the cloud market and has now become a core part of many commercial products out in the market. Since leaving NASA, he's now gone on as the founder and CEO of Nebula. Today, he's going to discuss the emergence of the private enterprise cloud. Please join me in welcoming Chris Kemp, founder and CEO of Nebula.
Thanks, Steve. Cheers. Good morning, everybody. I can't believe I'm competing with a Rackspace party. Good to see everybody this morning, and it's great to see coming in HP, Rackspace, who else was on there? Red Hat, all contributing and sponsoring this conference. So I appreciate everybody's support. So today, I'd like to talk to you a little bit about what we are seeing out there in the enterprise and the adoption of cloud in the enterprise particularly. So today's talk is about the emergence of the enterprise private cloud. I'm just going to cruise through this. So basically, everybody should be doing this. Makes sense, right? The ability to be incredibly agile, to give your developers and your employees the resources they need when they need them. Big data explosion, cost pressures, right? I mean, every enterprise should be well into an adoption curve of cloud at this point, but they're not. And so really that's what that's what we're talking about today. So why? We're seeing the cloud being adopted in internet companies. We're basically seeing small companies not even consider building their own infrastructure, but immediately go to public cloud services. We're seeing startups, we're seeing SMBs, we're seeing the edges of large enterprises experimenting. We're seeing CIOs doing pilots. We're seeing all this activity and all this hype, but we're not seeing adoption in the enterprise. So as I talk about the emergence of the private enterprise cloud, I'm going to break it down a little bit. I'm going to first talk about cloud. And I want to just reiterate the definition that Peter Mell and the folks at NIST came up with. When we're talking about cloud, we're talking about on-demand, elastic, shared, metered by use, accessible services. We're not talking about taking yesterday's technologies and rebranding them cloud. And I think that might be part of the problem, because a lot of enterprises have a lot of yesterday's technologies and yesterday's systems integrators that are largely responsible for the infrastructure that they've deployed. So when we talk about cloud in today's talk in the next few minutes, we're talking about true on-demand, elastic, shared, metered, accessible services. So private. I don't want to mince any words here. Basically, a public cloud is something that everybody can get to, and a private cloud should be basically the exact same thing, except behind the enterprise firewall. Meaning it should have the exact same attributes, might be a little smaller though, but it should be on-demand, elastic, shared, metered by use, and accessible. So we're really talking about the exact same end user characteristics, regardless of whether you're talking about a public cloud or a private cloud. And I think that's where we start to run into problems with the enterprise. Enterprises have all these challenges. As we talk to dozens of Fortune 50 CIOs and Fortune and Global 2000 CIOs, we found 5 themes that were really the underlying issues as their organizations grappled with making true cloud resources available to their employees. First of all, the culture, the maturity of the organizations that they were in. The ability for the existing culture, processes, technologies, tools, experiences, vendors, integrators to adapt to this new model where everything is dynamic and elastic, and that was really by far, above security, above anything else, the #1 barrier that these CIOs would talk about: performance. Everybody has performance requirements in existing applications that don't always map to what you can do in a cloud environment where performance is typically less consistent. Security, obviously, talked a lot about that at the conference here. Cost. You're going to hear from Alan over at Zynga about how the cloud was great. The cloud was wonderful. As their business grew, it became very expensive. And so especially if you have and can forecast your workloads, it's actually quite expensive to pay 10 cents a gigabyte. I mean, you do the math, that's $100 a terabyte, $1,200 a terabyte a year, $3,600 a terabyte over 3 years, the average lifespan of a $50 terabyte hard disk. So cost becomes a real concern at scale. And then architectural constraints. Existing applications often just don't like to run in cloud environments, and these architectural constraints are being increasingly addressed by public cloud providers. But what this leads to is a cloud paradox, which I call the enterprise cloud paradox. The enterprise cloud paradox is every attribute of cloud computing is in direct opposition to enterprise. So think about on-demand. Enterprises are on approval. I mean, arguably, enterprises define on approval. They've built complex workflows where multi-level organizational structures are required to approve budgets, to approve resources, right? So on-demand and on approval are opposed. Elastic, enterprises like to fix assigned resources to projects. They're the opposite of elastic. Shared versus private. I think the idea that a shared resource, accounting can use the same infrastructure that our public internet, that our marketing people, our salespeople use, this is kind of antithetical to how enterprises think about the infrastructure, where they like to isolate resources, whether behind firewalls, whether just physically isolate resources. It's all about isolation. I mean, we've been taught that this is how you achieve security, through isolation. Metered by use. Enterprises don't like to have things that are metered, that are unpredictable, that you can't budget for and plan for. They like to purchase things. If you look at the budgets of most enterprises, there's very little OpEx budget for infrastructure. It's all CapEx. Accessible. is somewhat diametrically opposed to inaccessible. So again, as you look at all of these attributes of cloud, there is a direct kind of antithetical paradox that exists in how typically enterprises like to do things. So that's the challenge with emergence. So how do you address this? And I think this is reflected in all of the different approaches that enterprises are using or are at enterprises' disposal to do cloud today. The public cloud, we've got great, innovative, incredible value propositions from companies like Amazon and Rackspace, but the challenge is with limited security controls, with the concern over lock-in, with high ongoing costs and with limited flexibility, enterprises look at these options and it's preventing emergence, right? Building custom private clouds, even if they call things, virtual private cloud, it doesn't get there. Building custom private clouds is hard, right? And we've always had the option to hire a great team of engineers and build these things ourselves with technologies from great companies like VMware and Citrix and Eucalyptus. But there's a lot of implementation risk. It's a big IT project. There's cost there. You have deep expertise you have to recruit to take these products and get hardware and software and network stuff to all work together to make these things true self-service, elastic, metered clouds. You also had the option to buy the solution. And, friends at VMware and Cisco and EMC will gladly partner together and give you a VCE solution. Increasingly, we're seeing companies take hardware and software and put them together as turnkey, quote-unquote, cloud offerings. The challenge is very expensive. You get locked in, and there's a high ongoing support cost. So I think these are the options that are available in the market today, and I think these are the options that are barriers to emergence of cloud in the enterprise. So how do you solve the paradox? That's the question. I think that you need to do 5 things. First, you need to support tens of thousands of employees with self-service provisioning tools and self-service management tools. And these are very different than what you might find in Amazon. I think Amazon's great for a web developer that needs some compute resources, storage resources, platform services. But think about the user experience that you would want to give a manager of that same employee, and it doesn't exist in Amazon. So I think you have to think very differently about how you would support elastic, dynamic, on-demand services in an enterprise. And a successful solution to this paradox from any of those vendors would support this notion of really employee-centric self-service provisioning and management tools. Second, supporting advanced security analytics and forensics tools, log analysis tools. I think this is something that's really missing in a lot of these solutions. Really seamless integration with the existing tools used today in enterprises to ensure compliance with various regiments of regimes of policy and security. And I think that's something that we're going to need to see in anything that emerges. Support for existing tools is another big piece. A successful emergent enterprise cloud will not introduce a single new management domain. And that's one of the challenges I think that a lot of vendors have in this space today. They bring new management domains in with the cloud. And so the network operations people, the security operations people that are achieving compliance through the tools and the processes and the people they've already trained look at this thing as a net new investment they need to make in learning and management and operations. The more we're able to integrate with the existing tools in these areas, the more we're going to see emergence in the enterprise. I think that cloud is all about economics. Not a single one of those attributes was a technology attribute. So unless we're able to show economic arguments to business units and users within enterprises, we're not going to actually see true emergence because cloud will be an expensive cost center. Everybody's using it. It might be very internally efficient, but it won't be externally possible to provide that visibility back into the business units that are paying for it. Very few enterprises have successfully centralized IT. And I think increasingly, we're going to see enterprises struggle with that because mission organizations are going to find it very hard to take services provided by the CIO and differentiate their businesses with them. And I think that as we see this, we're going to see an increased federation, and we're going to see business units attempt to try to do their own things. So I think unless those business units are able to understand the economics of the services they're consuming from some sort of enterprise cloud offering, it's not going to work, and we're not going to see emergence. I also think workload portability and infrastructure interoperability is key. I think any solution that threatens lock-in to any particular hardware or software And in particular, workload lock-in or data lock-in is going to be fraught with challenges of adoption. And so I think a successful emergent cloud platform will support true workload portability. And I was reading, perhaps it was Randy Bias or one of the folks who was speaking here earlier today in this conference. One of the things we really like to see is standards evolve around virtual machine portability, virtual disk portability, virtual network portability between hypervisors and between cloud service providers. And I think that's really the key, and that's not happened yet. So I think the real solution to the paradox is an ecosystem. I don't think a single vendor or a single company can solve all these problems. And I think the attributes of that ecosystem to solve this paradox are it needs to be ubiquitous across enterprises and service providers. A platform will not emerge that locks workloads behind the firewalls of an enterprise. A real enterprise cloud scenario will almost certainly in the next 5 to 10 years involve bursting workloads out into clouds that are incredibly wickedly secure, incredibly reliable, incredibly well geographically positioned in different international locations close to customers. And I think workload portability, ubiquitous interoperability into these environments between enterprises and global service providers is an absolute key requirement of this ecosystem. I think open and standards-oriented platforms are the only way to ensure that portability. So I think unless you've got a platform that is driven by a community that desires portability and interoperability between competitive offerings, you're not going to see this. And I think also whatever platform emerges, whatever ecosystem emerges here, needs to support innovation. I think if we only take a small handful of companies that have been in the business of serving enterprises for the past 25 years, and we lock out all of the innovation that's happening in all of these great startups like Nicira and Joyent that are coming out of Silicon Valley, we're not going to see a platform that will be sustainable, because I think the most interesting things that are happening in cloud today are happening in companies that have fewer than 100 people. So. And this is where I get to be the co-founder of OpenStack for a second. I think the only platform I see out there today that has the potential of being this ecosystem that will truly crack this is OpenStack. And I'd like to be proven wrong. I see some great innovation, and I see some great work coming out of Microsoft. I see some great work coming out of VMware. But I think they're going to find it very challenging when you consider the implications, the ecosystems that they've developed, and the lack of innovation in their ecosystem, I think, will ultimately create real challenges for them. So again, enjoy the rest of the conference here. Many of the companies that are driving this innovation, in fact, every single one of the companies that I saw here promoting this event are also promoting OpenStack and are members of the community, perhaps with one or two exceptions, but certainly appreciate their support and certainly look forward to the next few years. I think as I drive down Highway 101, 5 years from now, we're going to see a completely different set of names on the buildings. And that is the potential of cloud. And I think that is the potential of the ecosystem that is emerging around OpenStack. Thank you very much.
Thanks, sir. All right. Good morning, everybody. Everybody's wide awake. Everyone went off and had like a nice romantic dinner with their loved one or something like that. I had a great conversation in New York a little while ago about platform as a service with our next speaker. One of the interesting things about platform as a service is that it allows us to do things very, very well at scale because we let the people who are running the infrastructure worry about how to be efficient. So for the last 50 years, as we've developed higher and higher level programming languages, we've always assumed that as we moved up the stack, we were giving up speed. Assembler was really, really fast. C was pretty fast. Java was slower. And as you moved up and got more abstracted, you gave up efficiencies because you were further from the low-level machine. And that's a perception that I think has infected our thinking about cloud computing, because we view it as, well, if I can't get bare metal, I'll get a virtual machine. If I can't get a virtual machine, I'll get a machine image on a cloud. And eventually you're moving up to high-level programming languages that are sort of cut and paste, but you're giving up performance. Peter Magnuson is the Director of Engineering for Google App Engine, and he's going to spend some time talking about why that may not be true. Peter.
All right, hi guys. Let's see how this thing works here. There we go. All right, so my name is Peter Magnusson. I work at Google with cloud computing products. In particular, I work with Google App Engine, Platform as a Service. I'm not going to talk that much today about App Engine in particular. We have a booth here, so happy to talk to anybody here afterwards. But the key thing is that I want to talk about is some of the observations and some of the thinking coming out of looking at running these shared systems at a very large scale. App Engine today, these are some new numbers that I'm sharing today. We're now at 30-day actives of over 500,000 applications running on a single infrastructure. And they together serve up over 200 billion monthly hits of different sorts, all from page views to being back-end services. So this is operating at a fairly large scale, which brings to mind some of the things that I talked to Alistair about in New York a little while about that I was going to share today. So, but first I want to talk about Littlest Pet Shop. So Littlest Pet Shop is a $12 billion business. Just messing with you, it's nowhere close to $12 billion. But when I look at the amount of money my daughter spends on it, it makes me think that this must be a $12 billion business. So I had an experience 2 years ago that kind of reprogrammed me a little bit to thinking about the cloud, because I came at it from a computer architecture background, from a computer systems background. That's my research background, that's my engineering background. Thinking about it very much in terms of cycles and disks and arrays and grids and so forth. Initially approaching it, thinking it as just another large supercomputer, the sort of things I would have logged into in my grad school days. But I had an experience 2 years ago at Target when my daughter wanted to buy an airplane, a Littlest Pet Shop airplane. Obviously, there's airplanes for little pets. And it cost $30. So I'm swear this is going to become a $12 billion business. So I asked her, well, $30, all right, so really, you know, but you have to spend that, do you have that much in your allowance? Yeah, Dad, I have $275 on my allowance. What, really? And then she whips out her iPhone, because we're a gadget-rich family, and she looks up the Google spreadsheet on which I have the formulas that calculate how much I owe her. It's updated automatically. And she shows to me, yeah, Dad, look, you owe me $275. So I take out my iPhone. I've since joined Google. I now would whip out my Android. And I have write privileges, so I update that trick sheet and deduct $30 from allowance. It's then updated on her phone, and she can happily go off and buy this airplane. And that, to me, when I realized, wow, this is cloud, right? Because cloud isn't defined by the bytes and the disks and the bandwidth and so forth. It's really that it's everything that's not on your desk or on your lap or in your hand or in your server room. You don't really know where it is, but you can reach it from your browser, and you can probably reach it from your phone. And the next generation isn't even going to think about that thing on the other side as a computer. The kids growing up today are going to think of it as that something other thing that I'm talking to, be it the GPS that's running in my car, be it their allowance application on their phone, be it the grades they're getting from their school. It's just running somewhere else. That is the cloud. Again, looking back at how I approached thinking about the cloud initially, I just saw it as a progression of how you use technology. You know, your starting point is, and this could be seen as the life cycle of a startup. You start by running it in your garage, and you run everything yourself. Then you go somewhere and you rent the server somewhere, and you start basically outsourcing more and more of your stack. And at some point, you're going to the far right, which is a platform as a service, as it's called today, where you don't want to care about anything else. You just want to upload your code. And that's a design target for App Engine, is that you should have to know as little as possible about all these other things. But I would posit that this is just the beginning of the journey, right? Because the initial argument is that it's all about sharing the resources. We can be running lots of applications. And tying back to my earlier numbers, we're now running hundreds of thousands of applications from hundreds of thousands of different developers at the same time on the same infrastructure. So you get economies of scale and so forth. But there's a lot more to it. One is that we're running our services, our API services, enmeshed in this environment, right? So you don't have to bring up an email server on your stack and worry about it. You just hook into a service that provides it, and that service is running in the more or less in the same environment managed by in our case, Google. And that gives us economies of scale, right? Because our email server that you hook into is this little thing called Gmail. Right? So we use the same backends for Gmail as we do for App Engine. We have similar things for things relating to images, things relating to text processing, things are NoSQL solutions, the SQL solution that we just rolled out last year. These are all things built up to be sharing in this environment. And there's lots of, and this is more fundamental than just the computation. I would posit that this is a fundamental reorganization of human affairs. This picture here is a city diagram of the bazaar in Istanbul, which I think was built in the mid-15th century. So the notion of the marketplace or the bazaar is literally as old as society itself, or in terms of age of history and the age of our ability to build cities. In fact, one of the drivers for a city or a town was the ability to come there and trade. And you notice that we build a wall around it, right? And you notice that we standardize on communication. So these are streets connecting different services. And they'll get clustered. So you'll have the fish sellers in one area. You'll have the meat vendors in some other area. And you will have standardization on all sorts of interaction things. You'll have standardization of coinage, which was driven out of this environment because you want to facilitate trade. You will have standardization of identity management, show us your papers. Some of the very earliest usage of writing was these stamps that would identify that you as an individual, your sigil. That's nothing more than identity management, right? These things really, this invention of creating this environment so the city didn't own everything that was going on there, right? Because we know that the model where it was owned everything, the top-down, fully organized society, we would today call them communism. They've been tried in called different things over the millennia, but doing it fully top-down doesn't work. But creating the public place is effective, and that's what I would posit what the public cloud is going to become. You're going to start having you will have eventually a small number of public IT providers that will be providing more or less the bazaar and providing the communication parts, the standardizations within it. You will have the safety that when you've shown your papers to the soldier walking through one of those gates, you can be trustful that the owner of the bazaar has gotten rid of all the pickpockets as best as possible. Back in those days, they'd be hanging those from different corners just to underscore that they've been cleaning out some of the thieves. And it's all, what's the difference between a pickpocket and a bazaar 1,000 years ago and a denial of service attack against your firewall? I mean, it's basically the same parasitical behavior. So this goes way beyond just optimizing resource usage. Another example is gold, and this is a picture taken from the Federal Bank in New York, which I don't know if those of you saw the James Bond movie that was topicked on it, but it's based on a true situation. So in the early 1900s, by some estimates, 10% of the entire world's gold stock was in this one vault deep under Manhattan. Why? Because when you wanted to move gold between what was owned by different countries, it's really difficult to move them across seas and continents. So you would entrust this bank who would just move the gold from one storage for one country to another storage to another country. This is data, guys. This is the same problem we're facing now with big data. Big data has mass. It's becoming more and more difficult to move it between services. So another huge driver for the public space and the public IT cloud is the weight. And literally, if you look at the physics of information theory, information has mass. You have to move it. And we will get that aspect as well that will be converging to large applications. If you have a petabyte of data and you want to lend it out to somebody to do some processing on it and then charge for that, you can't be shipping that between servers. That has to be in the same data center. And of course, finally, the argument is sharing is good. And that's it. Thank you very much.
Thanks, sir. All right. Interesting look at what it takes to optimize pipelines and how to stand on the shoulders of giants. Our next speaker, Patrick Lightbody, I've been wanting to get up here for a while. The last conference that we ran, he was busy having a baby. Horrible timing on his part, but given that I've already ruined Mother's Day and Valentine's Day, I wasn't going to spoil that one as well. So he's decided to join us. He is the Senior Director of Product Management at a company that spends a lot of time testing the internet. And for him, that sometimes means things like spinning up 10,000 instances at once and then watching them all fall over quickly. So he's going to talk to us about what it's like to spin up massive numbers of machines at scale for the purpose of testing, load generation, and just basically making Amazon miserable. Patrick.
All right. All right, well, so yeah, I'm here, as Alistair said, to share some of our experiences launching and managing, in some cases, tens of thousands of instances. And like Alistair said, we're really just testing the internet at Neustar. So probably the best thing to do is sort of describe how we got there, or how I got there. So to kind of set it up, it was late 2008. Amazon was still beta, whatever that meant, and it was one region, relatively small compared to what it is today. And I was a software developer, and I found that load testing was really obnoxious with this thing called Ajax that was all the rage at the time. All the protocol traffic going back and forth was a lot harder to simulate. And I'd also been spending a lot of time working on an open source project, not related to the cloud at all, but a cross-browser testing tool you may have heard of called Selenium. And so I was contributing to that. So kind of those three things mashed together, and I got this itch to go do something about it. So what we built was basically the most inefficient DDoS tool you've ever seen. But it actually sort of made sense for our customers, and the finances all worked out. So I've got a little diagram that explains how it works, and this will kind of set it up how and why we're launching all these instances. So imagine you're on your computer, and you go to Neustar's services, its load testing service, and you say, I want to see what happens when a bunch of users hit my site. Well, what we do is we actually spin up a ton of Firefox browsers in the cloud on a ton of virtual machines. Very, very inefficient compared to traditional load testing, but definitely a lot of fun about learning about the cloud. So if any Trogdor fans out there? No. Anyway, so we would spin up all these servers, smash people's sites over, but sometimes we also blew up the cloud ourselves or ran into interesting little problems. So what I want to do is kind of share some of the tips we learned along the way to get us to where we are today. So today we launch well over 200,000 instances every month. So I think it, in terms of the up and down, makes us a pretty heavy user of the cloud. But we don't keep those instances on for very long. It's a hyper-elastic use case. Often they're on for 45 minutes or an hour, and then we bring them right back down, and then we bring them right back up. So we're not a Zynga or a Netflix where they've got thousands of servers that are just on most of the time or on for at least days or hours. We are very hyper-elastic. We've done at least 10,000 CPU cores spread over a variety of different instances and regions. And it's all done, this is probably the hardest part and the thing where we've learned the most, it's all done when the customer wants it, not when we want it. So we're not going out there saying, okay, maybe 3 a.m. is a good time to do it. It's whenever a customer comes up to our product, clicks a button, and says, I want to run this test. And so we've got to figure out automatically with our software how to manage and control all of these computers and get those resources from a lot of different locations and techniques. So how did we do it? So I'm going to quickly run through 10 little tips that I learned along the way that got us there to run all of these instances. So number one, definitely architect with the pricing structure in mind. This may be a no-brainer for some of you, but it's really important, especially when you're putting massive amounts of data, flooding it all over the place. So for example, in Amazon, the data transfer charge between instances in the same availability zone is free, between instances in the same region is a smaller fee, and then across regions is more expensive. So we made sure that we had little aggregators in every availability zone that would then aggregate up to a region and then aggregate up to a central storage location. And that was really important. If we didn't do that, our cost structure actually would spiral way out of control. And so definitely be keeping that in mind. It's kind of a new paradigm with the cloud where you really are trading off price and performance and price and functionality, and it's very obvious what you're doing versus in previous years where you're buying your own hardware and is kind of spread across many years and harder to gauge. The next one was the number of machine instances that we launched. We tried to keep that to a bare minimum. Even though we have lots of different types of workers and activities that we launch in the cloud, we actually started it with we always start them with a single machine image. And then on boot up, we then kind of configure them after they've started up. And the reason we did that, and someone here from Amazon probably can explain it better if it's not one of their secret sauce things, but the reason we did that is we found that we actually got better performance if we didn't try spinning up 10 or 20 different AMIs, but if we started with one, it seemed like they were almost provisioning out the disk images to these edge locations, and then we could spin up a lot of instances much faster. So that was based off of just a bunch of testing. Related to that, user data, that's how we kind of bootstrap these stem cell instances. We were using, for example, the Ubuntu images from Elastic, or however you pronounce that, which is a popular Ubuntu image that just out of the box you can give the Amazon machine some user data, and when it boots up, it can kind of self-configure. So that was really helpful for us as well. Expecting failure, that was a big one that we actually didn't expect. So that was a big lesson learned for us. There would be times, we're a big fan of the cloud, we're a big fan of Amazon, but there would be times where we'd launch 1,000 instances, and everything would look hunky-dory for a few minutes, and then 900 of them would come back saying internal server error, or we'd see huge blocks of machines just shut down. And it happens. It's not all the time. We actually get great reliability out of the cloud, but it does happen, and we had to work around that and deal with identifying those instances and picking them up. So just like with network programming, you should always expect fail, but even when you get a successful instance launching, it may not actually be there, so keep that in mind. We also use spot instances. That help drive our costs down and give us even more capacity. It's a little tricky because spot instances are more of an asynchronous conversation. And so with the asynchronous nature of it, you don't know if you're really going to get that instance. So we had to put in all sorts of algorithms to put out bids, but then grab on-demand instances right when we needed it. And the net result was we'd use a mixture of on-demand and spot to get the instances we needed just in time to build up the load. IAM and consolidated billing, those are nice account management tools that Amazon gives you. Really important when you're spinning up tens of thousands of instances. For example, if you leave 5,000 instances on over a weekend because your systems forgot to shut them down, that's a $36,000 bill over an extended weekend. It's important to keep an eye on your costs when you're doing this many machines. And so we would actually split out to different regions and use different accounts to kind of manage our costs with our customers. We also use EBS volumes in some cases to boot faster. You can actually boot an instance up, then turn it off, and now it's pre-configured, but it's got kind of a semi-warm disk ready to go, and we found that boots up much faster, particularly on Windows, where they have to restart Windows instances dealing with network names and things like that. So we got faster boot times, and we could have kind of a reserve instance that was regularly on, and it only cost even with a 10 gig image, it would only cost about $1 a month to keep an instance on sort of semi-cold storage. So I mentioned, could cost you $36,000 in our business over just an extended weekend. So it was really important to us to have some sort of Reaper processes that were completely separate from our main code line and actually written by entirely different engineers. And there'd be heuristics in there to alert our operations team when there were any problems with those instances. Sometimes we get false alerts, but we'd rather have a few of those than wake up with a bill that puts us out of business. So it's really important to keep an eye on that. And the last two are probably the most important ones. One is the cloud isn't infinite. There's this common misconception that the cloud can just let you scale forever. First of all, your architecture matters probably a lot more than any of the scalability you're going to get out of the cloud and the number of instances. But two, there actually are limits, and Amazon wants to talk to you about that, and so does Rackspace, and so does GoGrid, and so does every other cloud vendor. They're here to help, but they've got to work with you and understand your use cases. So related to that, And probably the most important was more of a social engineering lesson that we learned, which is you kind of want to be a good citizen in whatever public cloud you're using, or even a private cloud in your own network. Work with, in the case of Amazon, work with your Amazon account rep and tell them, hey, I don't want to screw up your guys' network. Do I need to do anything if we're going to suddenly pump gigabits of traffic through your networks, or if we're going to suddenly launch 2,000 instances? Are you worried that we might saturate all of some instance type? And we did that a lot, and it was a learning process, and we were continually updating our systems to meet the expectations and the guidance that we got from our account reps. And that's how we got to using lots of regions and lots of instance types and lots of spot instances. But don't treat the cloud like it's just some thing that's going to work out there, and you don't have to ever talk with the vendor that's providing it. They appreciate it, and you'll appreciate it too. So those are just some of the things we learned. I hope that was helpful to you. If you have any questions, you're welcome to email or tweet me anytime. Thanks so much.
Thank you, Patrick. Our next speaker has been such an important voice of reason in the industry over the years and has become a regular speaker here at Cloud Connect. He's an award-winning analyst, and he is here today to tell you that despite everything that we've been hearing about here at the conference this week, don't even think about moving your applications to the cloud. I'm going to let James explain that, but please join me in welcoming James Staton, Vice President and Principal Analyst at Forrester.
Okay, so you heard Chris talk about how enterprises have no chance of doing private cloud, so don't bother. You just heard Neustar say that if you're going to use the cloud, it's extremely complicated. You have to have complicated algorithms. There's no chance you're going to succeed in this. And you heard Google say that if you don't know 15th century history, you just don't get it. So you excited about the cloud? The reality that they are all presenting is really, really important, because one thing we have to constantly keep in mind is cloud infrastructures, they are not your traditional inside infrastructure. And as a result, you really have to think about what you're going to put there and whether it's actually going to fit or not. And that's why I titled my presentation what I did, because I really need to hammer home to enterprises all across the country here that you just cannot pick up the application running in your data center, drop it on a cloud, and assume it'll work. It's a really bad assumption, because enterprise applications just are not designed to work in environments like this. And if you don't get that through your head, and you don't pull it up the chain of command, and you don't push it down the chain of command in your organization, somebody's expectations are going to be out of alignment, and they're gonna be dissatisfied with a cloud experience. And that's very much what we've seen. So if you remember, I made some predictions at the end of last year, end of 2010, where I said that lots of enterprises were going to invest in private clouds this year, and the majority of them would fail. They don't fail because the technology isn't there. They fail because of this expectation mismatch. And that is really, really critical to understand. So if there's nothing else you take away from my presentation, take that away. Now, with that said, let's look a little deeper at this issue and then how to solve it. So one thing you have to understand, and you've already heard this from Chris earlier today, and you definitely should have noticed that through the other presentations that you've seen thus far, is that when you look at the enterprise infrastructure and you compare that to a cloud infrastructure, these are not the same thing by any means. They're extremely different in structure. One of the things that we take for granted in IT, and those of us that build and develop applications and put them into our corporate data centers, we assume that the IT organization and the data center take care of high availability and reliability. The cloud, we assume, will do the same thing, but they don't. They do not do high availability at the same level, nor do they do high availability for you. It's your responsibility to take that on. And this is what Forrester has said for a long time we call the uneven handshake, which is where you have to say, what is the service doing for me? What are they providing in the infrastructure? Where do they stop? And what do I have responsibility for from that point where they stop up? So all cloud services are abstractions. They abstract away from the point of the service down. So we know in infrastructure as a service, you get the virtual machine, you don't get to see the server, you don't get to see how the server is configured, you don't get to change all that. So when they give you a virtual machine, you sort of have to go on trust that they're going to make that virtual machine available. But to what degree? You have to think about that and understand that, and then you have to put the right operating system instance on top. You have to put a cluster on top of that if necessary. You have to put performance monitoring on top of that if necessary. You have to put the right middleware in place, and you got to monitor the whole thing and make sure it's highly available. So if you're an infrastructure and operations professional, is your job all that different? You just don't have to run into the data center periodically anymore. So if we're going to take our legacy applications and we're going to put them into the cloud, how do we actually do that? Well, first of all, that's a really bad question to ask. The second thing is you have to say, well, what does it actually mean to cloud enable the legacy? Because that's really more important, and that's why I chose this image here. Those of you that are fans of the Back to the Future chain of movies will recognize this came from the third of those films. You don't actually pick up your legacy and drop it in the cloud. You transform it. And the way you transform it is that you put links to your legacy that create a bridge between what the legacy did and what it's capable of doing and what the cloud is able to do for it. That means you want to concentrate on, why would I move something at all? Am I moving it just because I want cost savings? The cloud sure seems cheap. Is that a legitimate reason? Not really. It's actually cheaper not to move it at all. Like, let's use a different analogy and you'll see where the connection comes through. Quick pop quiz for you. What is the most green car that you could possibly possess right now? The one you already own. Because no new manufacturing takes place, no new natural resources get damaged to create that, and so it is automatically greener than any new car that you could buy or that you could build. From a legacy perspective, from a total cost of ownership, the thing that's sitting in the corner, if I don't do anything to that, it's actually a lower TCO, because I already know how to run it. I've already taken all the steps necessary to try to make it efficient. So if I'm going to move it somewhere else, it can't be for cost reasons. I've got to be moving it because there's some other value. Is it no longer achieving the agility or the productivity that we need? Does it no longer fit in the business processes that we're doing in our organization? Can it not reach out to my customers who are now coming in from different interfaces? If it has no ability to give a user interface to a mobile device, that might be a reason to transform. And transform is the key. So you're not going to suddenly go to SAP, for example, and say, hey, you know that SAP ERP instance that I've been running since 1985, I'd really like you guys to give me, make that thing do mobile. Is that okay? Can you do that for me? And by the way, I don't plan on upgrading. That ain't going to happen. So the way you do this is actually the way you've been doing transformation of legacy applications for a long time. In fact, during the dot-com period, we actually learned how to do this. We just have to sort of take our brains back a little bit, and we'll see exactly where that was. So what I mean by this is you take your legacy applications, and legacy doesn't have to be mainframe. It could be, frankly, anything. It could even be running in Windows and maybe even virtualized in your VMware environment. But you take these applications that are already done, and you don't really want to mess with that code, and you start to wrap them in what we call concentric circles. You surround that legacy application with new capabilities that run independently and can call back to the legacy system through the conduits that the legacy system already exposes. If you remember back in the early days of the web, we took applications that could do nothing but a green screen, and we figured out how to take green screen streams and turn them into HTML so you could see them in the browser. And we did this not by modifying the legacy, but by putting things in front of it. That's the concentric circle model. And so the way it works here is take your legacy application, all those interfaces it have, and surround it with a web infrastructure, something that can actually use this information, manipulate this information, do it in a load-balanced, spread-out, distributed organization of applications and components that can also expose web services. And when it exposes web services, you can put another concentric circle around them that allow new capabilities and new functions to actually tap into those legacy applications that you had in place already. Those of you that go out and travel on a regular basis, you probably are interfacing with new applications to determine what tickets are available to you, who's got the best fare, how long am I going to be stuck in the airport between flights, which seat is the best. None of those new applications would have even existed if Sabre and the other legacy travel industries did not take this approach back in the web days. So if you think about Sabre, just as an example, Sabre continues to book all the air tickets that you order on a mainframe. But what's nice about the travel industry, and you'll probably see this in your own industry as well, is that there are a ratio between looks and books, or reads and writes, using engineering terms. Understanding that ratio in the travel industry said that all this looking does not need to happen in the mainframe. We can cache out the information, and we can put API connections and conduits back into this information, and we can push that information to the outer layers. When you start to do that, you can actually strip functions off of the mainframe. So the mainframe no longer had to handle looks, and so we pushed that out. As you push functions out, as you transform individual functions and put them into the further out circles, the legacy actually starts to shrink. And that is where the big cost savings come from. So you want to tap into the cloud not for cost savings, but for transformational purposes. And so to get cloud right, there's a very simple set of things that you need to think about. First and foremost, don't think legacy, think new, think a greenfield, think enhancements to what you've already got in place. What new capabilities and functions can I create? And don't create them as more legacy code. Create them as these outer layers, these outer concentric circles. Then you're not going to move. You're going to transform. Hybrid cloud is all about taking things that run in these outer cloud areas, these new environments, and connecting them back to the tradition. Don't think hybrid cloud means public and private cloud. It doesn't. It means cloud and whatever. Third, if you don't want to run the legacy anymore, putting it onto infrastructure service or putting it on platform service isn't going to work very well. Outsource it. Get somebody else to run it for you who perhaps can bring some economies of scale and be more efficient about that. Or transform by getting rid of it and replacing it with a SaaS offering. And then finally, if you can't achieve cloud economics, you shouldn't be in the cloud. I think you heard that from Neustar, and you're going to continue to hear it from the rest of our speakers today. So with that, thanks so much for your time, and good luck with the next few presentations.
Did you want to field questions?
It's up to you.
All right, you got time for one, Sean.
Okay. I can't see any of you guys, so if you have a question, just shout it out. All I see is lights.
You're just going to have to yell.
You must have questions. Anyone from SAP here wants to take issue with me? I'm fine with that.
What do you see the spending in large IT organizations shifting between on-premise applications versus SaaS applications?
So this is a really good question. He asked about what is the spending shift going to look like between investment in existing applications and investment in the cloud. A lot of people like to paint black and white pictures here, where it's like, well, they'll spend here, but then in the next 5 years, it's all going to shift over there. It's not. The way you actually have to think about this is, if you look at all the deployment options that you have available to you as in IT, we're just adding more. We're not taking any of the old ones away. So when we add on cloud and we add on SaaS and other elements like that, those are new options for you to deploy applications and add new capability. What will happen over time is, yes, the investments and the money that you spend on older deployments, what we call traditional implementations, will decline. But they'll decline not because we're going to stop using them, but because we're going to shift more of that function as we transform organizations and transform business flows into the other side. So a good way to look about this is the big data topic. So big data, everybody says, is just all this stuff that happens in the cloud. No. You got a ton of that big data already sitting in a data warehouse. And while most of what's in your data warehouse might be what happened in the rear view mirror, and all the stuff in real time is what's happening in the forward mirror, what's happening right now, there's really not a lot of insight you can get from what happened right now if you don't know what happened in the past as well. And you'll have to connect the two to really see if a trend is happening. We talk about in market research that 2 points don't make a trend. You have to have a minimum of 3 to see the pattern. And 3 is at least going to be 2 in your data warehouse and 1 up there. So we're going to continue to invest in things we have on premise, and that's going to continue to be the bulk of what we invest in because we know how to. We still have to learn how to use this new stuff, and so the investments will happen here, and they'll happen at great growth rates. But overall dollars, it's going to be a while before those really start to take off. And if you want to see what the specific numbers are that we put in place, you can certainly look at the Forrester forecast for that.
All right. Thanks a lot, James.
You bet.
And you're here for the rest of the conference?
Today.
Yeah,
Yep.
So if you have questions, hunt James down in one of his panels or discussions or in a hallway somewhere.
Great. Thank you.
Thank you so much. So our next presenter, we moved some stuff around in the schedule so he could be with us. He gave an amazing presentation in Las Vegas last year, just astonishing about the rate of growth of Zynga as just a machine, and the sheer number of hours that we spend playing casual games is astonishing. Alan has a storied past. He was Clouderati before there was Clouderati. He has founded and been involved in the early days of companies like Cisco and Digital Island. He's been an investor, one of the smartest guys I know on infrastructure, who can go toe-to-toe with people on the TCP/IP payload structure and debate headers and IP toss, and then get way up to how to manage tens of thousands of node clouds efficiently. Zynga had some very interesting news hidden within their reports yesterday that Alan's going to come out and share with us. So looking forward to hearing some exciting stuff from Alan.
Faster? Which button? Morning. My name is Alan Leinwand. I'm CTO of Infrastructure at Zynga. I'm going to spend a little bit of time this morning telling you about how we use the hybrid cloud, combination of the public cloud and our private cloud, something we affectionately dubbed our Z Cloud. Zynga has a mission to connect the world through games. And that means finding a way to bring social connections. We think of gaming as social. We think of it as accessible from multiple types of devices. And we think of gaming as fun. Matter of fact, at Zynga, we believe in play. We want to bring play to the internet. We know that people are beginning to play more on the internet. And we think that play needs to be thought of in the same way people think about sharing, shopping, or even searching on the internet. We've also started to see some data points that tell us that play is an activity that's becoming more and more accessible, something that a lot of you are doing on a daily basis. And that's something that we really strive to do on the technology side and on the infrastructure side at Zynga, is really to make the infrastructure enable play. Some of our games you may have heard of: Farmville, Yeovil, Cityville. Some of you might be playing Words with Friends right now. I'll try and keep your attention, but if you're playing it, that's okay. But just don't play me. But our games are social. They're fun. They connect to your friends. They connect to your family. They connect you to people on your social network. Matter of fact, the infrastructure behind that is something that really drives those services. And while you think of them as games, you think of your farm or your city or your empire in Castleville, what you're really experiencing is a network of 240 million monthly active users. And the infrastructure behind that to drive that, to make those changes on your farm, to allow those words to be played in Words with Friends, to unscramble that scramble on your iPad or your iPhone. That's something that takes a lot of technology, a lot of innovation, and a lot of scale. Not only does it take scale, from Zynga's perspective and from our perspective on our teams building infrastructure, there's a bit of a challenge. And the challenge is that Zynga is a globally distributed company, multiple locations, lots of developers. And what these locations show you is where Zynga developers are developing new social games, new social mechanics, new ways for you to have fun. And these features are coming daily, multiple times a day, multiple times a week. And they put challenges on the infrastructure to change, to make sure those live services evolve, to make sure that there is that new feature that you come back to and want to play with on your farm or in your city or on your mafia. It's something that we find very exciting when we look at infrastructure, is that infrastructure as a requirement for handling these different types of workloads is something that's a challenge to build. It took a lot of innovation from our teams to build, and it's really something that we've been striving to grow and scale over time. But let me take you a little bit back to how we started and what we did. When Zynga first started building out infrastructure to build social gaming, we actually did a classic model. We went to a co-location facility. We started buying servers and networks and firewalls and all pre-cloud type of things. And we started scaling the infrastructure in a way that matched the needs of our players. And that's always been our goal. When you go to play one of our games, they're always there. They're always ready for you to play. But what we found out is people had these moments of delight. They had these moments of joy in playing our games, and our games took off. And the infrastructure didn't really scale. We ran out of things like data center space. We couldn't get cooling fast enough. We had an issue with getting servers up and running, and we needed more flexibility and more scalability. The inflection point for us was back in 2009. Back in 2009, we launched a game called Farmville. And Farmville in the first 6 weeks went from 0 daily active players to 10 million. And then it didn't stop. It actually went to 25 million daily active users in the first 5 months. And that was an inflection point for us to realize that we couldn't continue to scale and grow infrastructure at a way that met the pace of our players and the demand of all of you out there having fun and being social. So we quickly moved to using public cloud infrastructure. We took Farmville and we started to use things in the public cloud, and we grew the infrastructure there as well. We flexed and we scaled with provisioning tools, and public cloud became an absolutely critical and essential part of our infrastructure. As we moved through time and we continued to use the public cloud, and we continued to grow and scale with Amazon, we realized that we were sort of renting where we could own. And we decided that it made sense to sort of think about how to build infrastructure that would live inside of Zynga, that would allow us to scale on our own, that would allow us to take that infrastructure and grow at the rate of our players' demands. And we had an idea, and we came up with this idea called the Z Cloud. Now, when you're looking at building a private cloud, the thing that's most critical for us to understand and most critical insight that we had is when our games were scaling, when they were going at a vertical line, 0 to 25 million daily active players in a very short period of time, for example, on Farmville, it's really hard to get ahead of that growth curve. But if you can start to see growth curves that are slightly less than a 90-degree angle, still growing at exceptionally fast rates, but less than a 90-degree angle, you can get ahead of that growth curve. You can build for that capacity. And that's what we started to do. So we built and operated in multiple geographies something called the Z Cloud. The Z Cloud is operated like a public cloud. If you squint, it kind of looks a lot like Amazon Web Services, but it's self-contained inside of Zynga's facilities. It's safe and secure. It's a place for our players to go to experience fun in their social games, but we know that it's within our own premises and within our own control. And we launched games in the public cloud still. One of the challenges we had was that although we were growing very fast, our games were growing fast as well. And that meant that while we were continuing to use the public cloud and scale with the public cloud, we were building up Z Cloud at the same time. And we had a philosophy that we talked about through last year called cloud bursting in reverse. What we would do is we would take a game and we'd launch it up into the public cloud and Amazon Web Services, because we weren't quite sure exactly where the slope of that line was going to be. Once we were able to plot the slope of the growth trajectory in the public cloud, we would take that game and we'd move it back over into Z Cloud. And that was something that we spent a lot of time doing in 2011. We also made a commitment to own the base and rent the spike. And what I mean by that is to build out infrastructure, make capital investments in our infrastructure, and make sure that our private Z Cloud was able to scale, focused on meeting and scaling the needs for our games and players. To give you an example, when we launched Castleville back in November of 2011, Castleville grew from 0 to 5 million daily active users in 6 days. Castleville was launched exclusively and scaled exclusively on Z Cloud. So a couple numbers that we like to talk about in terms of the infrastructure and what we've actually done. Z Cloud went from proof of concept in our labs, running code, not really live, to in production at scale in less than 6 months. We've actually had the ability in our data centers, in our facilities, giving our automation, our innovation, our monitoring, our scalability, to actually provision 1,000 physical servers within 24 hours. And we've done this on a number of occasions. And to give you an idea of the order of magnitude growth we've seen, between January of 2009 and January 2012, we grew the number of servers on Z Cloud by 2 orders of magnitude. So what does this really end up meaning? What this ends up meaning is our game developers, our game studios, the folks that are making these fun games that most of you are playing right now, I suspect, now consume infrastructure as Z Cloud in a scalable, seamless way. We made aggressive moves to leverage our own infrastructure. And we actually launched the first new piece of IP, the first new game on Zynga's Z Cloud in June of 2011, so just about 7 months ago. At the same time, we continue to use Amazon. We continue to grow in Amazon. We continue to connect our private Z Cloud to the public Amazon cloud. That hybrid cloud was a strategy, maintains to be our strategy, always is going to be our strategy going forward. But we did make a big move. The big move we made was in January of 2011, approximately 20% of our daily active users were actually running in zCloud on our own infrastructure, and 80% were up in Amazon. By the end of last year, we had flipped those numbers. So 80% of our players were now accessing games in zCloud, and 20% were up in Amazon. So not only during 2011 were we building out facilities, were we launching games into Amazon, were we watching the slope of those games in Amazon and moving them to zCloud, we actually moved a large majority of our daily active players onto zCloud in 2011. But zCloud's still a hybrid. We love the fact that it's private and public. We need that flexibility. zCloud is our primary infrastructure, but we have to leverage the public cloud. We need Amazon Web Services being there. We need that flexibility. We don't know when the next moment of delight is going to find itself into our players, and they're going to have that surge onto the infrastructure. We don't know when the next feature is going to hit that people are going to love and want to use throughout the world. We obviously know when games are releasing and when things are happening, but these are living, breathing services, and things happen 24 hours a day, 7 days a week on the infrastructure, and we need to make sure it's very flexible, always able to meet the needs of our players. So this allows us to have this flexibility, and by the way, it's a hybrid card, a hybrid road, and Linkin Park's hybrid theory. Those are really hybrids, and that's how we think of maintaining our infrastructure. Very hybrid, very flexible, able to look at best way to effectively and efficiently utilize the infrastructure. So I'll give you a little tease and wrap up here. I'm actually doing an hour-long case study tomorrow on zCloud, tomorrow morning. And that case study really focuses on two things. Once we bulked up zCloud, and once we understood that zCloud was going to be our primary vehicle in the hybrid cloud model for our games going forward, we actually decided we needed to focus on availability, and we needed to focus on performance. And we've done some really interesting things in terms of innovating on availability, innovating on performance, and hopefully some of you will find your way over to that session tomorrow. So hopefully you've enjoyed hearing a little bit about what we've done at Zynga with our private and public hybrid cloud infrastructure. Thanks very much.
Thanks, sir. All right. Good lineup so far. We're trying to keep things moving nice and fast. We have a pretty provocative discussion coming up next. Originally, I was going to do my rant about root being a right and stuff today, so you'd all be fired up about how open computing mattered a lot. Because of our opportunity to get Alan out here after their earnings call, we decided to move that to yesterday. So if you can take yourselves back to that moment of passion where you felt like you were going to go out and start a revolution and buy the T-shirts that were in the lobby, and root being a right and open being important, I want to take you back to that moment. I know it was a wonderful moment. And then I want to bring you here today, and we're going to have a discussion about openness in clouds, because this is something we've heard a lot of today. I would say that we're in an era of open washing. We're done with the cloud washing, right? The number of brands that have the word open in them, it's like all the domains with the word cloud in them got used, so we decided we're going to put the word open in front of things now. Not that I'm being cynical or anything, but I do think that this move to openness is something that's got a lot of marketing buzz and is not necessarily well defined. And there's a lot of contradictory definitions of what it means to be open and why that's important. So I'm going to ask three people. We're lucky enough to have three heavyweights from different companies who are behind much of this open cloud movement to come out and talk about what it means to be open and how to fight the war on general purpose computing. Joining us today are going to be Brian Chi from Rackspace, Samir Dholakia from Citrix, and John Gates from Enstratus to talk about the other war on general purpose computing. Gentlemen, if you want to come out and join me out here. And we're going to spend a little time talking about what it means to move to open and how you avoid getting locked into systems with openness and so on. So I'm going to ask each of you a really simple question in a Twitter-length response. That's 140 characters or less, depending on whether you want to include a hashtag. How do you define open? Go ahead, you're first.
So open is really about providing you the type of control that you need in your infrastructure. You have the ability to choose whatever technologies that you want as you build your cloud.
All right.
I think it's cloud on your terms, anywhere you want to put it, and with any service provider.
So you would say it's choice. You're leaning a little towards portability.
Flexibility in deployment models and portability and compatibility as well.
Okay, and Samir?
We focus, it's all about collaboration. It's the opposite of control. It's in our world view, the opposite of VMware's approach. It's about collaborating.
That is a very, very short answer.
How's that? How's that?
That's not just Twitter like. That's, yeah.
I'm picking up where my friend Simon Crosby left off.
That's hashtag link. That's nice. So maybe each of you wants to talk for a couple of minutes about what you see as your open initiative. Maybe give a bit of background of who you are and what you see as the role of your organization in championing open clouds. I'm going to start with you this time, Samir.
Sure. My name is Samir Delanki. I'm the GM of our Cloud Platforms group at Citrix. That group includes our Zen Server product line, our Cloud Stack, cloud orchestration layer, our Cloud Portal, which helps you build a cloud on top, and then the group that focuses on delivering desktop as a service, which is core to the Citrix business value proposition. We are deeply, deeply engaged in helping organizations build open clouds. Alan, timely talk, has built a zCloud on top of a number of technology components, of course, but core among them are Cloud Stack and Zen Server. That is a very significant environment, as he described. Many, many thousands of nodes of servers using our open source-based software, Cloud Stack and Zen Server. And so we're very aggressively pursuing what we believe is the battle for cloud computing, and that war, in our mind, is very much about open versus proprietary. We are very committed to driving success in the open world, and our singular belief, and I say this often, if VMware is as successful with vCloud in the service provider community as they have been with vSphere in the enterprise data centers, we will have all just watched the birth of the next great monopoly that will extract rents for the next decade. And I believe that is not only not only bad for Citrix, but for the industry and customers. And so we believe it's very important that the collaboration, that the group of folks like us get together so that open source wins in the cloud and not closed.
All right, John.
Yeah, so I'm John Ingates. I'm the CTO at Rackspace, and obviously I sort of represent Rackspace and Rackspace Public Cloud, but I also spend a lot of time talking about OpenStack. OpenStack is an open source project that provides the ability for companies, users, to build their own cloud based on open source technology. There's a cloud storage component that Rackspace contributed in our early days, and then NASA came along and joined forces with us, and they contributed a big compute component. So it provides the foundation for infrastructure as a service clouds. There's a number of projects that sort of coexist within those within the project to sort of complement the storage and compute. But to give you sort of the idea that it's really the way that you could build a Rackspace cloud or an Amazon-style cloud in your own data center. That could be a public cloud. We have competitors actually now using OpenStack to build their own public clouds. Quite a number of companies have announced. A lot of companies here at this conference are talking about OpenStack clouds. Rackspace has services around OpenStack to where we can provide, again, managed services on top of that cloud so customers don't have to manage it themselves. And so open for me is really, again, flexibility to deploy on your terms, on your hardware, using your own choice of hypervisor, giving you really the choice and flexibility, and then interoperability between Rackspace and other cloud providers.
All right.
Hello, my name is Brian Shea, and I'm responsible for our enterprise cloud business at Red Hat. So that includes everything from our CloudForms infrastructure as a service offering to OpenShift, which is our platform as a service offering, our management portfolio, our security products, and so on. From a Red Hat perspective, open And building an open cloud is really the most important architectural approach that you can take as you consider how are you going to get the full benefits of a cloud. If you take a look at a lot of the challenges that enterprises have in their own data centers today, a lot of different management silos, a lot of complexity, how are they going to get the types of efficiencies that people like Rackspace and other public cloud providers can have? It's only by getting to the benefits of cloud, but you need an open cloud architecture that encompasses everything that you're doing. If your cloud only works on a narrow set of your infrastructure, if you have to put it in there and it doesn't deal with your existing applications and so on, then having a cloud is not going to provide you with the full benefits. You're not going to get all this agility and cost savings that you're looking for if your cloud is not open and able to extend to the types of workloads that you want. Another really important factor is that as you take a look at what it means to be open, there's a lot of really key properties, and these properties are important measurements of what it means to be open. This includes factors like, is there a community? Are there open standards? Do you have freedom around IP and so on? And so as you take a look at all these different characteristics of what it means to be open, this serves as a really good litmus test of how open are you and what benefits can you really achieve.
All right, so we've heard open's good. There's a paradox here. Limiting choices and forcing people onto a smaller number of possible platforms, which is unopen, right? Taking away their options, not letting them do what they want, not letting them go underneath the covers, forcing them to work at a higher level. And you can argue that that's not a bad definition of closed, or that is a bad definition of closed. But if we limit people's choices, then we force them to become more homogeneous, which means we can optimize them. As you heard from Peter Magnuson earlier, if I build something on App Engine and I need document conversion, my document conversion is only one of millions of documents that Google is doing. And so I don't get to rewrite my own document conversion code, but for the same reason that we don't all get to build our own cars, because then we get to drive on consistent highways with consistent speed limits and have consistent crash tests. Openness tends to lead to sprawl in a way that can that can undermine the economies of scale cloud is supposed to bring. So there seems to be a bit of a paradox here that limiting choice is actually good for us in some cases because it gives us economies of scale. Discuss.
Yeah. Well, yeah, I'll take a first cut. I think one is the key is having openness at the core so that people can come in and collaborate and contribute and augment and have access to those things. I think that at that higher level of abstraction, part of the reason is it is about establishing standards and trying to get folks to build on a platform and trying to coalesce the industry around that. Citrix, as some people here may know, has been deeply engaged in the OpenStack community from the outset. We acquired Cloud.com with the CloudStack platform that is also 100% open source and has had a great deal of success. And we've been doing and will continue to do everything we can to try to bring together the tremendous traction and asset that we have with CloudStack and the community that's growing there with OpenStack. And our organization, Citrix, has talked with Rackspace quite a bit. We're willing to contribute CloudStack into the OpenStack community. So we're trying to do everything we can to keep it together so that it doesn't fracture, so that it doesn't split, because we do think that that is important to establishing a standard on which people can then go build higher up.
I think it's also a particular problem if you sort of define it the way you did, where you say it's one company sort of defining the standard and keeping it tight and locked in. I mean, you don't have any opportunity for innovation then. You don't have any opportunity for somebody to go in a completely different direction. If OpenStack, for instance, decided we're just going to copy the AWS APIs word for word, line for line, we would never be able to create anything beyond that. That we'd have to just wait for them to invent something and then copy it. And that's not really the way you want.
But we haven't really changed TCP/IP in a long time, and we got a lot of innovation on top of that. So didn't we do well by getting consolidation around a standard there?
Yeah, and I think that's what OpenStack represents is a very strong community around one mission, which is an open version of the cloud rather than something that is so tightly sort of controlled by one organization that that no one else can have a role to play. The ecosystem is important. If you think about all of the people that are represented out there in the floor of the show, a lot of those people's businesses are betting on being a part of a vibrant ecosystem, not being sort of left out of an ecosystem that is potentially undermining their whole business model.
So just to dig into that a little bit, at Rackspace, is your public cloud built on the same OpenStack infrastructure that people get in the private cloud, top to bottom?
Most of it is, and it will be completely by the end of this year.
So your goal is you can get it from us or someone else.
Yeah. In fact,
Just
we're
like
publishing our reference architecture.
Right.
It's called referencearchitecture.org. You can go look at it, and we're trying to be very transparent. We don't see that we get a competitive advantage by having something that no one else can have on a technology
Well,
level.
and this is Facebook opening up its data center plans and Netflix opening up stuff on GitHub every week. They publish something new.
We like that.
I'm going to shed what used to be a competitive advantage,
like
and I'm
that.
going to focus on higher level stuff.
We like that. We approve.
How do you feel about that? I mean,
I agree with that, and I really think it's a bit of a false dichotomy to say, your choice is either open or complexity. Because if you take a look at it, open is really about providing you the freedom to choose your architecture and flexibility going forward.
I think my point was open and complexity, or closed and simple.
Right, but even there, just because you have an open architecture doesn't mean you have to naturally introduce complexity into the environment. So the fact that I can choose many different options doesn't mean I have to, but I can bring in what I feel is the best set of technologies to address a lot of rapidly changing use cases. So for example, in the previous session, we heard about how Zynga adapted its different models where they started in their own data centers, they went out into Amazon, and then now they're doing reverse bursting. All these different patterns that you're looking at, because we're so in the early days of cloud, you don't want to trap yourself or lock yourself into one particular architecture that's imposed on you so that you don't have the ability to adapt and to be able to change as you go forward. So being open doesn't mean that my environment right now is complex, but I have the ability to change at will as I need to.
So I'm not sure I buy that. You say being open doesn't mean it's complex, but very few people I know have Linux as their home PC they watch TV on. I mean, a buddy of mine once tried to convince me to use Myth TV, and he was like, oh, it's easy. Look at these words going by. And I'm like, I just want to watch a movie. Can't I just grab the remote? And yes, I couldn't get root on that TV. It was a bad thing, but I just wanted to watch a movie.
So Red Hat's not in the consumer space, obviously, but no, certainly you may not be using Myth TV, but I bet if you surveyed the audience here and you asked them what operating system was running on their handsets, you'd find about half of them are using Linux and Android and so on. So certainly it can provide the foundation that you need in terms of
but
very valuable.
Linux that's rooted, or Linux and Android that's locked down by the carrier?
Well, so again,
I'll take that survey, we can turn the lights up, but I'm going to guess that most of them can't get root on their phone.
But again, the point is not that someone is going to go ahead and change the code in their cloud or change around the source code. This is why Red Hat provides value to our customers. Customers come to us so that we can make the open source code consumable and packaged so that in the enterprise context, it's the equivalent of getting, not a Myth TV, but an actual TiVo type of experience. And having an open source is just one key element in terms of what makes an open architecture. If you want to be open, it's not just about the code, it's about having an open community. It's about being able to deploy on the infrastructure of your choice. It's about being able to have unencumbered access and freedom to the intellectual property. It's about having open APIs and so on. If you're not open across all these different dimensions, then just because your code happens to be open source, it's not going to provide you nearly enough benefits.
So let me ask you about stacks, right? We all love TCP. But I remember a day where I had to choose, was it Vines or DECnet or IPX SPX or TCP IP? And the brilliant Simon Ordley, who's talking later on today, pointed out that, look, it was a moot point because one of those stacks was public, TCP IP, and we all just eventually went there because nothing could fight with the de facto public standard. And first question, I guess, is, are we in another stack war, only it's not the networking stack, now it's the cloud stack, and pun intended, and at some point we're just going to choose the public standard that's the de facto standard, and that's the way it's going to be? Or where are we in that battle? Is this like one of you is Vines and one of you is DECnet and one of you is IPX?
Well, I mean, I think that OpenStack, we would like it to be a broad enough standard that people sort of look at it and say, well, that's the way we ought to build clouds going forward. I mean, I don't know if that's going to be the case. I mean, you have today a number of ecosystems we talked about mobile phones. There's an Apple ecosystem that's very vibrant. There's an Android ecosystem. So maybe there's a couple, but there won't be dozens. There won't be multiple, multiple tens of ecosystems. There'll be a handful or less. And so I think that what we're going to see is that we want to have an ecosystem where we do have openness to at least collaborate on things. We have some consistency for people to be able to deploy a private cloud that works in their context the same way that a public cloud works in ours. And that only happens if we're collaborating in the open and talking about it. I mean, we have design summits every 6 months where we get together and we invite the community to come talk about what clouds ought to be. It's not Rackspace's vision for what a cloud ought to be. It's the community's vision for what a cloud ought to be.
Sure, and I'm being disingenuous by calling you guys that. Any one of you could be the TCP/IP, and I think I'm a pretty big proponent of moving up the stack to things like Cloud Foundry and OpenShift. There's another battle happening right there between OpenShift and Cloud Foundry versus Zen and VMware. These battles are happening at different layers of the stack concurrently, right?
Sure.
One of the things that really bugs me is we talk a lot about cloud availability and performance, and we spend all our time talking about machines. And it seems to me that every big cloud problem I encounter is a data problem, not a machine problem. So like if someone said, make me a highly available email app, I'd stand up an email server in 50 cities. The problem is when I want to access an email and I accidentally edit it in 2 places at once, there's all these issues of concurrency and latency and so on that happen, right? So to me, open cloud computing is as much about open portable data and being able to get the metadata out of the cloud as it is about being able to run a machine image in a certain format that I can crack open and carry around. Tell me about the role of data in open clouds.
So I think that data, you're absolutely right, it's a hugely important factor of being open. I actually think it's more than just data. I think there's actually 4 different dimensions that you have to be open and portable around if you want to be open at all. And that's around computing, data and services, programming languages, and applications. So let me just run through that really briefly. Sure. From a computing standpoint, you've got to be open in terms of being able to access computing capacity at the provider of your choice. Your choice of physical infrastructure, your choice of virtualization technology, your choice of public cloud providers. But it's not good enough just to be able to say, I can run my application here, I can run my application there. To your point, what do I do with my data if I migrate my application? What do I do with my application dependencies if they don't exist everywhere that I want to run? If they only exist in one particular cloud, I'm locked into that cloud, even if I can spin up the VM somewhere else. From a programming standpoint, you mentioned platform as a service. You really have to be able to write your applications in the frameworks and the languages of your choice and to be able to deploy them into the cloud of your choice. If you can only use one framework and it only exists at one API, again, you're locked in, you're not open, you're not portable. And then finally, you really have to consider from an application standpoint. If I don't have any kind of automation, if I have to deal with provisioning and management in one way in one environment and a totally different set of tools in another environment, I'm never going to take advantage of openness because it's too cumbersome.
All right, John, Sumit, you got thoughts on data?
No, I was thinking back to revisiting that conversation around the stacks and the APIs and standardization, kind of all your questions kind of bundled up. I think one of the keys, I think, will be in a very open dialogue in the community around whether that is Amazon API, OpenStack API, and from a cloud, from our perspective at Citrix, CloudStack, for example, has a very high degree of fidelity with the Amazon API. And simply because of just the mass and scale of the Amazon cloud and the ecosystem and workloads that have already been built around that. So now we have, I think there'll be a very interesting discussion for all of us over the next 12 and 24 months to see around building towards an API standard, whether there's a de facto standard of one that has grown to be $1 billion business and running away versus a community one that has been driven around OpenStack or others. And I think that will be an interesting discussion, and I think it touches on a lot of the different points you mentioned. We'll have to see how things play out.
So data, I think, is one of the things that actually holds people back from cloud adoption in a big way because they sometimes feel like it's hard to get data up to the cloud. It's massive. It's a tough job, and they're also worried about getting data out of the cloud once they've put it there. I think there's a risk of closed proprietary platforms holding us back even more because they become islands of data that really can't be, you're stranded. You've got data stranded there. The more you build to a proprietary key value store or some sort of big data architecture that isn't open, that it isn't portable, the more you're really locking yourself in for the long term.
So, I mean, I don't know if you guys saw it yesterday, but I'm a huge advocate of the open model. I'm just trying to be the jerk that.
No, I understand, yeah.
Because all three of you are going to agree, and an agreeing contest is really boring. But tell me what that looks like if I'm using your cloud. I mean, the example I heard yesterday, and admittedly, closed platform, but Amazon's Elastic Beanstalk's a great example of, hey, you can use this self-configuring Elastic platform. But there's a big red button over here, and if you push it, you're on your own. You can go get your machines, but we're not going to scale them anymore, like, caveat emptor. Tell me about what's going to happen to reconcile this very open, you can get root, do what you want model with the, hey, clouds are elastic and self-healing and automatic and efficient and they make you quick. There's got to be a button in there that says, I give up the right to elasticity and automation in return for self-determination. What does that button look like in the future?
So I think one of the tensions that you're bringing up is the tension between people who want rapid access to capacity, what the cloud is really good at delivering, elasticity, self-service provisioning and so on. And you take a look at, what enterprises and people who are managing the cloud care about, how do I make sure that my environments are in compliance, that I've got standard operating environments, that I'm dealing with this kind of governance issue or that kind of regulation and this kind of policy and so on. And these are very much two issues that are in tension. And from a Red Hat perspective, one of the things that we focus very much on is how do we empower people so that as they start taking these capabilities around application lifecycle management, systems management concepts, and bring them into this new world of cloud so that you can get these kind of capabilities and the benefits that come from being open, but from an IT governance perspective, you also continue to retain control. How do I know who launched what applications into the cloud? How do I know what's going on with them? How do I know what patch level they're running at, and how do I manage that, and so on? These things also become very important.
Okay, guys, quickly, because we're
I just want to make sure Amazon's not the only guy in town that has the button. I want to make sure that the companies that are presenting at your conference next year, there's 3 of them that also have a button that can activate the same kind of services in whatever cloud you want to activate them in.
And I would just add to that, I think there is this private-public hybrid world where guys like Alan and Zynga that wanted more control are going to do it behind their firewall, but on a cloud-like architecture, on an Amazon-style cloud or a Rackspace-style cloud, and then be able to connect out. And when they do connect out, they will be probably giving up some rights and some controls, but for a great benefit. And I think that people will make that choice. But I think the key is a shift from a server virtualization-centric view of the world, where I'm adding management and self-service on top of a server-vert environment, to a true cloud-like architecture. And I think that is going to be the big trend, and the connection, the federation of how much control I have over the open on-premise versus from a service provider will be a choice that every organization just makes.
Great. All right. I'd like to thank our 3 panelists for taking my abuse for the last 20 minutes. Thank you all very much.
Thank you.
I'm going to bring out our next presenter. We're always trying to find end user case studies, and particularly case studies that involve enterprises. Yesterday you heard how Beth Israel Deaconess is changing its business model and trying to deal with some regulation in the cloud. Our next application comes to us from the world of air travel. Philip Easter helped to build the mobile application environment for American Airlines atop Microsoft's public cloud service called Azure. And so Philip's going to come out and talk to us about mobile app development using cloud platforms. Phil.
Good morning. I'm Philip Easter from American Airlines. How many did we fly here? I hope you all got upgraded. So I'm here to talk about what you could consider old legacy company, how we are embracing the cloud. You could say we've had an affinity for clouds for quite some time, about 80 years. But at American, we're looking at how can we not move, but how can we create new opportunities in the cloud. And I think I agree with one of the speakers earlier. There's a great opportunity for new services around legacy systems. And today I want to talk about how we've introduced a mobile component using the Microsoft Azure platform. First, a little propaganda. So we are a pretty large airline. We go to 260 airports, over 3,300 daily flights, 900 aircraft, and recently we just put the largest order in history. We're going to be upgrading all those MD-80s. If you have a chance, go check out our Facebook. We have some pictures of a new 777 that introduces some new amenities. One of the features is a self-serve bar. You might like that. There you go. And of course, 86 million passengers in 2011. So everything is mobile for us. You, our customers, you're constantly mobile, going through our airports, getting on our airplanes. hopefully not standing in queue. You're constantly mobile. Our employees that work with you, they are always mobile as well. At the airports, they're moving around. They're constantly being reassigned. Mechanics are constantly moving around different aircraft. So these two different forces are always mobile. Our planes, obviously, that's our asset. Our planes are always moving around the network. And our equipment on the ground is constantly mobile. So American Airlines has a key investment for mobility. Mobility is really going to help our airline, improve our airline, ultimately improve customer satisfaction. So where do we get to the apps? So my job is to figure out how to connect mobile technology to our customers and how to bridge the gap where there may be times where we don't show our softer side. So we feel mobility has an opportunity for us to enhance that. So currently we have over 3 million downloads. We are on all the platforms. We're in all the stores. Also, we're on e-readers. More and more e-readers are being used at the gate and on the plane. Another fact, a little tidbit you may not know, is all of our applications work free Wi-Fi on the airplane. So you don't have to pay for Wi-Fi to use our applications. This is convenient because in air you have the opportunity to check connecting information, other services that you might need. So flight status. If you did a report on all the calls that our applications make, flight status is #1. That's the one that most of our customers are very apprehensive about. Is my flight on time? Has the gate changed? Has the time been modified, not delayed? So flight status is constantly called. It's one of our, it's our highest #1 mobile app request. Gate times and planes, always changing. So here's kind of a diagram of big picture of how our operation works down to the mobile device. Currently we have an AA private. All the buzz about clouds and small devices connecting to cloud systems that do all the intelligence. 40 years ago, that was a mainframe. So we are still somewhat legacy. We have a lot on the mainframe. We've moved much of that to mid-range as well, but that all sits here hidden in our AA private system. So in order for us to create a robust, more scalable service and get those services out to mobile devices, we had to spend the time to create a web service product for mobile devices. And that really does the transferring of legacy system data, security, and all that to mobile devices. So we have all these mobile devices out there in the network connecting through a proxy agent back into our systems. And that works very well, very efficient. But each of these devices is its own device. It's calling several times to our systems. So recently, we've decided to launch on Windows Phone. Nice, elegant platform. Potential is pretty good. So we said, let's launch on Windows Phone. So we worked with Microsoft. They had some great local engineers at Dallas. And we sat down and they said, let's look at this holistically. We just don't want you to replicate what you're doing in your current implementation. Let's look at some other services that we can employ here, and that's where we came up with Azure. So the talk kind of talked about what are some of the things that your application does. And a really true great mobile app does 3 things very well. And one of those things is flight status. So let's zoom in on the cloud here. So what we did is we said, let's abstract this another layer. Let's create a worker role that will connect to your mobile web services. Let's create a database to track and look at all these flight information. And we'll have a web connector. And that collectively will then talk to your mobile web service and back down to all these devices. And if you have a Windows Phone, what's nice about that, you can use these active tiles, and our application actually will update the main tile with flight change or gate change. So what's nice about that is we can push information to this application without you having to actually launch the application. And obviously, if that's the number one thing that people are using, let's push that up, let's bubble that up. So what we effectively did here is we abstracted another layer to new services that are commonly called. Instead of constantly pinging and hitting our back-end services, we're caching those in the cloud, which the title of the presentation was turbocharging, so there's your turbo. So we can do a one call basically to many out in the clients. And what's nice about this is that it allows us to then start adding new services into this, this architecture. It also allows us to maybe move other devices to this. It gives us more security. Airlines are very secure. It gives us more security. It gives us instant elastability. So it really was a good solution for us. The other option that it allows is that we're looking at is how can we then allow additional APIs into this service and open that up to third-party developers. And that's something that would be very exciting for us to see a new development using our data. But again, abstracting it far enough out that we feel secure about it. And I think that's the end of my presentation. So if you have any questions about what I talked about, just put a dot in my name at aa.com, and I'd be happy to answer any of your emails, non-customer service related. Again, thanks for your time.
Thanks, Philip.
Yep.
Okay, thank you, Philip. Okay, I mentioned yesterday that we were holding a little contest for speaker evaluations, and I want to announce our winner for so far, Vikram Chandrasekhar. I'm sure I'm butchering his last name, but he's won an Amazon gift card. So there's a good reason to fill out those session evaluations in addition to helping out that great charity that we spoke about yesterday. Okay, our next session is going to be talking about the new public cloud, open, developer-focused, and business grade. Here to lead this next session, we have Biri Singh. He is Senior Vice President and General Manager over HP Cloud Services. Please join me in welcoming Biri Singh.
Thank you, Steve. Good morning. My name is Biri Singh. I'm with Hewlett-Packard. I am going to spend a little bit of time with you this morning talking about two things, give you a view into how HP looks at what we call hybrid delivery of cloud. And I'm also going to talk a little bit about the HP public cloud and the set of services that we're working on. It's currently in private beta, and we'll be rolling it out later this year. So thanks for taking the time. I appreciate you spending your mid-morning with us. Let me walk you through things. So the way we think about hybrid delivery, a couple of things I want to sort of cover here. HP has a set of cloud solutions. We've actually been in market and been quite active on sort of the traditional on-premise private cloud space for the last few years and have been reasonably successful driving our converged infrastructure story, which is all about server storage networking. We actually serve, I think, 8 of the top 10 most traffic sites. We sell gear to 4 out of the 5 top search engines. We sell gear to the top 3 social networking sites. So we understand the concept of scale out. We've done a lot of work in innovation in driving core infrastructure. And converged infrastructure, which is something HP innovated, has essentially sort of become an industry category that most vendors are sort of adopting and following today. So it's on the strength of that that we've sort of started thinking about hybrid delivery. And when we say hybrid delivery, it's really about spanning a set of solutions across sort of 3 main areas. One is an on-premise private cloud approach, and we've got a set of solutions there. The other is what we call managed cloud, which is essentially managed services, which we're delivering through our services organization. So this can be anything from standing up environments, whether it's a SAP environment over 6 months for a customer that's got to burst out or has a certain demand spike, or it's running Exchange servers for customers, or it's doing large-scale outsourcing. And then finally, there's a public cloud, which is sort of the new effort, and I'll spend a little bit of time sharing with you what we're doing there as well. So across this, the way we think about hybrid delivery is you have to be actually able to not only span the 3 environments. We don't talk about hybrid cloud. Hybrid clouds are what customers have. Hybrid environments are what customers deal with. As an IT vendor, it's our responsibility to deliver across a mixed environment. And so we're working on solutions. So the way we do that is actually focusing on 3 layers. So infrastructure transformation is an important piece. Application transformation, application lifecycle management, on-premise legacy models to, let's say, a completely loosely coupled web services model driven out in a public internet-based cloud. So managing for that is a fairly important focus for us. We're spending a lot of time thinking through that part. And then finally, information. So infrastructure, application, and information, both structured and unstructured. We acquired a company called Autonomy that does quite a bit of unstructured information for the enterprise, and sort of bringing that together. So the point on hybrid delivery for us is across multiple environments, but also up and down, if you will, the stack, the complete stack, infrastructure, applications, and information. And the third thing that I want to point out is orchestration here, and I call it orchestration with the big O. In simple ways, the way we describe it, it's sort of service provisioning your environment, standing it up, tearing it down, and managing it, and having quality of service around it. Orchestration is a huge deal, and we're spending a lot of time sort of, figuring this part out, getting smart on it. We think in order to be successful for both enterprise, ISVs, developers, IT ops focus, having a solid orchestration model that not only deals with VMs, but really application services, runtimes, databases, and information is critical. So for us at HP, we're spending a lot of time getting organized in dealing with being able to manage across these environments up and down, and orchestration is a big part of what we're focused on. So that's sort of a high-level grounding on what hybrid delivery looks like for HP. Let me spend a bit of time, and actually I'll point out one other thing here. What we've seen most enterprises take on is there's sort of 2 things going on here. One is enterprises that have arrived at it from a highly virtualized environment. You get to 70–80% virtualization, and you're dealing with a lot of automation and control over your environment. And then they look to try to move up the stack into sort of a self-service effort. And it's very different. If you're trying to actually implement a cloud environment, reconciling that to a virtualized environment leaves you with a few choices. Tends to be a lot of lock-in, but you also end up managing very different environments. The panel earlier on, you heard a few of the panelists talk about some of the challenges there. If you're trying to implement a cloud-like environment on sort of the right-hand side of this slide, you're dealing with things like self-service at both infrastructure and applications. And you're typically trying to tie that back to some level of control, whether it's your LDAP directory for your users, or using your users to be able to tie back your modeling, your service provisioning model. It gives you sort of a more secure governance model to be able to implement to. And finally, when you get out to the right side, you're really trying to be the true model of a services broker, which is deliver the right service at the right time. And then be able to be efficient with the way you'd manage your infrastructure and how you run your sort of IT operations for the business. So we're spending a lot of time essentially taking our hybrid delivery model and saying, as you start your journey from sort of virtualization, there tends to be a stop, and you have to have sort of a critical path. So how do you manage both a virtualized-driven approach as well as just building, quote-unquote, clouds, private clouds on-premise, and then extending out to a more of a public cloud service? So back to the slide I had here, hybrid delivery for us really is trying to manage that evolution that we see IT enterprises going through. So that's sort of the basic definition. Let me spend a few minutes on our view of the public cloud. So we've been spending this last year working on delivering the HP public cloud. We'll be in market. We're actually in private beta with the service now. And essentially what we've been focused on is really doing 3 things and trying to be good at those 3 things. First of all, we want it to be a business-grade cloud. We're completely convinced that a company like Hewlett-Packard has to deliver an SLA-based cloud, and we will, and we have to provide quality of service that's meaningful. And we think we're spending a fair amount of time on that, not just quality of service, but a secure environment as well. The second thing we're working on is really being open. So we've embraced lots of open source movements. We're building part of the infrastructure on OpenStack. We've worked with higher level cloud services like Cloud Foundry and a lot of other PaaS environments that are also fairly open. We have had the WebOS effort at HP open source recently. We had a big part in driving that part. So we're really trying to be open and be transparent in the way we are building out the infrastructure. And the whole idea is we don't want to push any type of lock-in. And then the third effort is really, it's all about focusing on not just developers, but IT operations. Because in a hybrid delivery model, you have to manage developers, ISVs, enterprises with their lines of businesses and be able to accommodate those needs. So building a unified experience for IT ops traditionally, as well as developers, sort of where we're spending our time. So the HP Cloud Services, what it looks like essentially is we're focusing on these sort of key areas. So the HP public cloud, our infrastructure piece, like I said, it's built on HP converged infrastructure, built on HP software, and we've leveraged the OpenStack environment to sort of get this to market. We've been in private beta for about 4 months and have had a really good response. If you get a chance, I'll send you, go to hpcloud.com, and I'd love to get you to sign on and try it out. The other things we're focusing on, so the idea is not just deliver a core cloud, but really work on 4 key areas that we want to sort of be very good at. So platform as a service, the notion of an ecosystem, hosting workloads, and then orchestration is kind of the key areas, and we bring this together in terms of a marketplace. So for us, for a public cloud service and the set of services above it, what we think is important is to be really good and smart about billing and metering at sort of a core level. Really being thoughtful about how we approach orchestration, as I talked about, and then finally using a marketplace as a way to sort of monetize and bring the ecosystem together. That's kind of the high-level approach here. So HP Cloud isn't just about core compute and store. It's actually a whole set of services built on top of it. So if I talk about that for just a minute, here's reference examples of types of ISVs or SaaS companies that we've talked to and are engaged on sort of a classic use case. And so there's a concept of ISV 2.0 that I like to talk about, which is really about pure SaaS companies or ISVs building next generation services really are now focused on getting their environments and their applications built out on cloud-like environments. And so a good example here would be Workday, which has a colo and works with a classic MSP. They're now saying we want to actually integrate on a service like HP Cloud and be able to sell and offer their whole HR suite, not only through the HP channel, but obviously be able to take advantage of the types of services we've built in. The PaaS platform that we're sort of working on is fairly open again. We've sort of standardized on Cloud Foundry as kind of the core, sort of the encapsulation layer for the runtime. And we've worked with other partners like an AppFog or ActiveState or CloudBees to actually add value to the various components, whether it's the user experience or it's an IDE or it's a particular type of use case that we're trying to solve for. So our approach in platform is really to give a IDE, a cloud-based IDE, multiple applications, language and frameworks, support multiple of those, and that's where sort of Cloud Foundry steps into it. And then have a whole set of management services underneath it, as well as third-party services that we can add value to. And for us, platform, really the key things we're trying to do is really focus on what the runtime and the set of data services behind it really are. Everything else really should be driven through the ecosystem. So that's sort of HP PaaS in a nutshell. We have actually some demos in our exhibition booth out on the exhibition floor. If you're interested, please go take a look. We've done some pretty interesting integrations that will be available later this year. And finally, our ecosystem, again, some reference companies here. We're working with some great partners. But just to give you an idea, the way we approach the ecosystem is really 2 things. There's technology partners and third-party services we want to enable. So whether it's an Informatica or a New Relic, AppDynamics, or it's a billing partner like Zuora, we want to be able to essentially eat our own food. So as we're working with them, we actually turn that around and offer it as a service available through the marketplace. And then the second category of partners are really our channel and systems integration partners and technology partners we would actually go to market with. So that's sort of a little bit about how we're building out the ecosystem. So marketplace and ecosystem for us go hand in hand, and your platform, in our opinion, is only as good as your ecosystem is vibrant. So we're spending a fair amount of time there, and you'll see HP take quite a stance in building out and actually investing in an ecosystem over the next couple of years. And then finally, as I pointed out, interoperability amongst clouds is a big deal for us. I talked about hybrid delivery, but we fundamentally believe orchestration is about not just managing sort of your bare metal environments, it's about also managing VMs and also managing application services above it. And a great example of that would be to abstract away for a language platform everything else other than the runtime and the database. And as a developer, that's really the only two things you sort of care about. Everything else should be managed. So whether it's auto-scaling or load balancing or billing metering underneath it, those are the types of services we actually feel like we need to be able to offer developers. So our thinking when we come to looking at cloud services is we want to focus on developers, ISVs, developers within enterprises, and offer them choice and offer them as much open environments as possible. So the other thing you'll see from us later this year is the HP Cloud Directory, the HP Cloud API Directory. We're going to publish all of our APIs and actually firmly believe in that code speaks when it comes to sort of being able to talk about, you know, what services we have and what's open and what's available. So that's a little bit about sort of what the HP Cloud services look like, and I tie them back to the hybrid delivery model. So we're really focused on doing an end-to-end where it's an on-premise, mostly enterprise-driven model, and they want to burst out to public services across the internet, but they also want to build out their environments on-premise. We're dealing with managed services or managed hosting, if you will, and a whole set of services around that. And they're dealing with a whole public set of what you typically would call cloud services out there. So that's essentially kind of the time we're spending and the areas we're focused on. As I mentioned, we've got a booth. Would love to show you some demos. We'll be speaking at 4:30 later this afternoon on the floor, and we'll give you sort of a good sort of view on all the different things we're working on here. So if you get a chance, please do go by the HP booth. As I said, we've had a private beta now for a few months. It's done quite well for us. You can go and sign up. We'd love to get your feedback. We'll be going to public beta later this year, and then we'll be rolling out the service sort of on a global level throughout 2012 and 2013. So stay tuned for that. You can follow us online, and we'd love to get your feedback. Other than that, I'll be available for most of the day here to connect with you, and if there's anything I can help answer after the chat, would love to meet you. Thanks for your time. Bye.
So we've spent a lot of time over the last couple of days talking about the technical issues around cloud computing, some of the scaling issues, some of the open versus closed issues. One of the things we haven't spent a lot of time talking about is the legal constraints around it. The Cloud Connect event tends to focus on the enterprise cloud adoption. And in many cases, enterprises are not going to adopt something unless there's a well-understood legal and regulatory framework. Today, that framework looks more like a patchwork quilt. And our next speaker, Robert Holliman from the BSA, is going to spend some time talking about the balkanization of cloud legislation, cloud standards, and what we can do to address that. Robert.
Good morning. I've got good news and I've got bad news. And you all know the good news, which is the cloud is growing fast. The bad news is that if we don't watch out, governments might chop up the global cloud into little pieces. Now, I've been in this industry for 20 years and I've seen this movie before. Sometimes lawmakers and regulators seem like they just can't help themselves. They adapt bad policies that harm the potential of great technologies. And with the cloud, Our biggest risk is they may make it difficult for data to flow across international borders. And in some countries, they are already doing things that could tilt the playing field and prevent fair competition. Today, I'm going to show you what we're up against. I'm going to give you a preview of a new report that the BSA will release next week. What this report does is it benchmarks laws and regulations in 24 countries that represent 80% of the global ICT market. Now, the study paints a pretty daunting picture, but it also points you to where the best business opportunities are in the short, the medium, and the long term. Before I get into the details of that study, however, let me give you a sobering thought. Imagine a cloud where data has to move across borders the way that people do. Long lines, bottlenecks, backups. Politically, that's exactly what we're up against. Technologically, it would be like having a series of walls and fences around the world. They would slow down the kind of trade in digital services that should otherwise boom in the cloud era. This is the global economy, after all. Why shouldn't you get access to the technology you run to run your business from anywhere in the world in a cloud environment? If the best solution comes from Argentina or Poland, so be it. And it goes without saying that why shouldn't your customers be everywhere in the world? But all of this assumes the right regulations are in place. We can't have trade preferences or regulations that distort the market. Otherwise, it would make the architecture of the cloud into kind of a Rube Goldberg machine. Now, this is what the real world looks like now. It's a patchwork. Countries like Japan and Australia, shown in green, have good policies for the cloud. We've analyzed them in categories like security and privacy and cybercrime and trade. They all get good marks. Other countries like Brazil and China, shown in red and orange, they have a lot of catching up to do. And what you see is a sharp divide between advanced economies and the developing world. Now, that's not surprising. But what is surprising is what you see when you look at countries that are doing well, and there you find that there are efforts by countries to wall themselves in with conflicting laws and regulations. Let's start with the European Union. Countries like the UK, Germany, France, they're logical markets for US-based cloud firms. Indeed, all the EU countries are off to a good start. But lawmakers in the EU are putting their thumb on the scales. They're doing things with regulations to keep non-European cloud firms waiting at the border so that local firms can catch up. For example, they say they have concerns about America's privacy laws, about America's Patriot Act, but it's a red herring. The truth is they see the cloud as an opportunity to reshape the technology market in their favor. Now, if one country stands out as the right model, it's Japan. Indeed, it's a mature, tech-friendly market. And Japan, of course, is an island country, and they know how important it is to be connected to the world. Japan's laws promote the cloud. They balance privacy and security concerns with those around innovation and growth. Japan has strong intellectual property laws that protect your business interest. It has a great IT infrastructure so you can grow your business quickly. For cloud computing to reach its full potential, we need more countries to take that approach. In the short term, you can look at our scorecard as a roadmap to the best current market opportunities. think about the policy landscape in the context of market size, and here's what the world looks like now. The chart shows the best policies on the right side of the scale and the biggest markets on the high side. The places in the top right are all great bets. They're Japan, the UK, and the US, which on this graph would be off the charts in terms of market size. They are all very good markets with good policies. At the bottom right, you'll see a group of markets that are smaller markets, but they also have good policies. Places like Canada, Australia, Korea. Over the long term, however, we have to fight hard to get countries that are behind the curve on cloud policy up to the rest of the world and to a higher standard. Otherwise, they themselves will become a drag on the global cloud economy. Those countries on the left side of the chart are especially important when you consider how fast some of them are growing. Watch what's going to happen to China, Brazil, and India in just the next few years on the left side of this chart. They are definitely on the move in market size. All of them are becoming powers in the digital economy, and everyone in this room expects that to continue. But what's not clear is whether their cloud markets will be open to you. Think about China's Great Firewall. Think about China's requirement to have a partner with a local joint venture. We all know that the cloud doesn't scale behind a series of walls. So how do we create a level playing field for the cloud era? Let me propose that we need three main things. Number one, we need more consistent privacy and security policies. We don't need everyone's laws to be identical, but they have to promote good data stewardship while also encouraging international commerce. Second, governments buy a lot of technology, and we need governments to throw their weight around in a constructive way. They can shape a marketplace if they let the best technologies win. And third, we need to promote innovation in the cloud the same way we promote innovation everywhere else. That means protecting your rights as you create new products for the market. It means stopping new forms of cybercrime and theft. Getting all this done, and getting it done right, will take a lot of work. But I'm incredibly optimistic, and I'm determined to work with you to break down every barrier to a truly global cloud. In Washington, D.C., there's an old adage. If you're not at the table, you're on the menu. So too it is, unfortunately, in the cloud economy. If we don't make ourselves heard, then the cloud will get stuck in that proverbial long customs line that I showed you a few minutes ago. Lawmakers need the technology community to point them in the right direction. So please, watch for our report that will be released next Tuesday, the 22nd. It can be found at BSA's website, bsa.org. Share those detailed findings with your friends and colleagues, and let's make sure everyone knows what's at stake. Thank you very much.
Thank you, Robert. Well, this concludes our keynote program for today. Thank you all for being here. We're a few minutes over, so please make your way over to the breakout sessions if you're going to class, or to the expo floor. The expo floor is now open. I'd like to thank you all for being here, and have a great rest of your week here. Thank you.
Together. Pretty soon you're gonna be dead.